Okay, so today we're going to wrap up some of the stuff we started talking about yesterday with combinatorics. So in terms of assignments now, I posted one assignment that is your notes from today and yesterday and the homework from today and yesterday. That will be a 20-point grade. There should be 20 easy points. So for those of you who are needing points to try to push the grade in the right direction, look there. Let me make sure. I want to make sure that I'm actually not on mute right now. No, I'm not on mute, so I think we're good. Just in terms of grades and points and things like that, that's a 20-point grade, so that can help push you in the right direction. I am posting the Delta Math assignment that I talked about yesterday. It will be 4 assignments, 1 for each unit that we've covered. And you know how it breaks it, Delta Math breaks it up into little topics. Delta Math breaks it up into little topics. You know, you have several problems about each topic. I'm putting 1 problem about each topic. That doesn't mean that you only need to do 1 problem to practice. It means find out the things that you know well and do that 1 problem as a good brush up. And then the things that you're like, oh, this is where I struggled. Then you can make it do as many problems as you want to do. It will keep regenerating problems as long as you want to. Yes.
Have you entered the AMA?
Probably not. I don't think I have.
Okay.
I think I finished grading them within Canvas. You see,
Yeah, I thought I read it.
I don't think that I posted those grades. I'll check and make sure. I don't think that I've done that. So, but anyway, I can't link from Canvas to Delta Math, but I can't, you don't submit within Canvas, y'all know that. It's just a separate program. But the assignments will be there. They are not there yet, but they will be, so that over the break, whenever you get to the point where you're like, okay, I can start thinking for the exams, they're there for you to work on. I want you to go home and rest and enjoy family and not have to worry about school, but I also want you to have that there as a resource if you want. So my recommendation for how you should begin preparing for your exam is go to Module A and make yourself a checklist of important topics and things that we talked about, formulas and whatever else. Just these are the key points from that unit, just to kind of remind yourself of those things, and then start working through the Delta Math. And again, there will be 1 problem on each topic that is required, but you can do as many of them as you want to give yourself the extra practice. The exam problems will come from exactly the same resource, so you will see very similar wording and format. So if you do all of those problems that are on the review, you will have seen something like everything that will be on the exam. No surprises. Does that make sense? So work on that. That will count for significant points, because in order to do those problems and get credit, you're having to do math and get it right. It's not just, hey, fill in something on a study guide that you can do mindlessly or copy somebody else's. Everybody's going to have different problems. You've got to do your own work. And in doing that work, you should be getting yourself very well prepared for your exam. So this gives opportunities for those of you who are struggling with the grade and want to pull it up. It gives you opportunities to be able to get the points for doing the study guide, and then also do better on your exam because of that preparation you've done. So are there questions about any of that? Other thing that I want to mention is, as I've looked through grades, or back up, if you are not logged into Delta Math, you need to get logged into Delta Math. I put the code for the teacher code on Canvas, so look and make sure you're logged in, because like I said yesterday, I still don't have the right number of people on the roster on Delta Math. And so I guess I need to go through and see who's missing, but make sure that you get logged in if you're not. Also make sure that as you're practicing, you're letting me know if there are any technical difficulties with the program not working the way that it should, because since your exam is going to be on that, we need to troubleshoot all of those problems well in advance, so that when you take your exam, everything's working fine. If I want you at some point in time today to go look at your grade on JCampus and make sure that you have credit for everything that you think you've turned in. I've put in several zeros recently for lots of different people for not turning things in. And I'm not going to follow up with you and say, hey, you didn't turn this in. I'm going to give you a 0, because if I don't have it, I don't have it. But I usually get people saying, wait a minute, I did submit that. Why don't you have it? And it's you know how submissions sometimes work on Canvas. So I want you to be responsible to go look at your grade and make sure that you have credit for everything that you think you should have credit for. If there is a discrepancy, please bring it to my attention, send me a message, and I will look into it. Also, if there are things that you have zeros on from previously in the semester, and your grade is not where you want it to be, then send me a message about what's possible for you to be able to work on over the break to be able to get some credit for some places where you have some zeros. I'm not giving full credit on anything that's late at this point, but if you've got some things that you've had zeros on and want to redeem some of those points to be able to get yourself out of the hole, then talk with me and we can make a plan for doing that. Any questions on all of that preparation stuff? Okay. So again, please make sure that you check your grade and be aware of where you stand right now and whether there's something missing. Your grade on Canvas is not your grade, but you haven't taken tests in Canvas, and so the Canvas grade doesn't mean anything. The grade that is your official grade is your Canvas. How did we do with the combinatorics problems from yesterday?
The Mississippi.
We'll talk about that. Yeah. Okay, Mississippi was tough? Okay, we'll talk about that. Anything else other than that one? Okay.
I was kind of struggling with that.
Okay, we can talk about that one too. So let's look. I'm going to do a problem different from the Mississippi one first. That's not what I want. That's a little bit easier. So I asked earlier today for somebody to give me an example of a word that has the same letter repeated at least 3 times. And somebody gave me this word, and I like it. That's appropriate. All right. So let's think about, the Mississippi question said, how many different ways are there to arrange the letters of the word Mississippi? Same question here. How many different ways are there to rearrange the letters of the word December? Well, if none of the letters were repeated, the answer would obviously be what? If none of the letters were repeated, it would be 8 factorial, because there are 8 letters and we can arrange them in lots of different ways. But I'm going to do something right here to show you what happens with the repeated letters, because that's what makes this hard. So what I'm going to do is write the word December. With colorful E's. Okay? The E's are all the same. When we arrange them, it doesn't matter what color the E's are, it still makes the same arrangement of letters, right? But when we count that 8 factorial, what we see right there counts as one arrangement, and this is going to count as another arrangement. We've counted that twice. But really, it's the same arrangement of letters, right? Because the letters are all the same color. I just put them in different colors so that you can recognize what's going on there. So, are there any other arrangements of the red, green, and blue E's that would be different from that?
Green, blue, red.
Green, blue, red. Red, blue, green. How many different ways are there to arrange the 3 colorful E's? 3 factorial. So basically, every time I write an arrangement of letters, I can rearrange those E's in 3 factorial different ways. So every time I count the number of arrangements, I'm counting the same thing 6 times. Does that make sense? I'm counting each one of those arrangements 6 times, but they all mean the same thing. So I need to collapse those 6 things into one so that we don't have to worry about what color they are. It's just the same arrangement of letters. And the way we do that is to take that 8 factorial and say, I need to divide out 3 factorial. I've multiplied everything by 6. I'm counting it 6 times more than I need to, which is 3 factorial. So I need to divide by that 3 factorial to say, let's not account for the rearrangements of those E's. Does that make sense? So when we look at the Mississippi problem, how many letters are there in the word Mississippi? Lots of repeated letters. So without the repetitions, we would recognize that the answer would be 11 factorial. But there's so many S's and I's and P's that we can rearrange in other orders that we're counting way too much. So What's one of the letters that can be rearranged? Okay, the S's. How many S's are there?
4.
How are we going to take into account those S's? 4 factorial. There are 4 factorial ways for me to arrange those different I's that would all look the same. So I need to divide by 4 factorial. Can you finish it now? I gotta account for all the repeated S's. So I need to divide by that as well. How many S's are there? 4 S's. So we're going to divide by another 4 factorial. And then 2 P's, so 2 factorial. Does that make sense? So basically, it's like, now that you see that, whatever the word is, count how many letters, and then look for repeated letters and how many times they're repeated. Any letter that's repeated, count how many times it's repeated, like December had 3 E's, divide by 3 factorial. Multiple repeated letters, count how many, each of those. Does that make sense? You obviously wouldn't want to write down all those possibilities. You would never be able to do that. It's too confusing and it takes too much time. But that gives you an idea of how it can be done and how many that would be. So you can calculate that. If you're calculating that on your calculator, be very careful because all of this is denominator, right? So if you were typing this into your calculator, you would want to type in 11 factorial divided by, put parentheses around all of that. What'd you say, Mike Lamb? So the 4 factorial and the 4 factorial and the 2 factorials, and you can get an answer there. I'm going to post the answers to the part A and part B of the homework assignment, but I'm not going to post 11 factorial divided by 4 factorial, 4 factorial, 2 factorial. I'm going to post the actual numeric answer. I need to see the numeric answer, but also the calculation that leads you there. So you'll know if you got it wrong because your answer doesn't match mine, but it won't necessarily tell you how to get it right. I want you to try to figure out how to get it right. Questions on that?
I have a question.
Yeah.
So, is there ever gonna, like, I don't know if I did this right, but if there's a problem, like, say it stops, it starts at 11, stops at 6. Like, how do you will obviously want to write that 11. Like,
So in a few minutes, we're going to look at the notes where it says working with factorials and kind of figuring out how to manipulate those a little bit. So if you hold that thought for a minute, we'll go back to that. You also mentioned the question about the license plate. Let's look at that one for a minute. What were the conditions that it said on the problem about the license plate? We wanted to have, y'all remember? 2 letters, 5 numbers. Adjacent means what? Right next to each other. So if I put a 5 in the first position, I can't have a 5 next. Those are letters anyway, so I can't have 5s in those either way. How many letters can we choose from?
26.
And how many digits can we choose from?
9.
You count to 0 as well. So 10.
Oh, 10.
So we'll count to 0 and it'll be 10 digits. So the first 2 are letters, and then after that, it's going to be numbers. How many ways are there for me to choose the letter that goes in the first blank? Once I've used P there, I can't use P again. So how many ways are there for me to choose what goes next? 25. Okay. How many ways are there for me to choose the first digit? It doesn't matter what came before it because it was a letter, so it's not going to be the same thing. So 10 ways to choose that. Once I've chosen that that's going to be a 2, how many ways can I choose the next one? 9. Is this going to be a factorial? So let's say I chose that next number is going to be 5. So in the third blank, I can't have a 5, right? How many numbers are there to choose from? Can I have a 2?
No.
It doesn't say I can't use 2 twice. It says I just can't use 2 right next to each other. So it'd be 9 again. The only number that I can't use is the one that's right next to it. Yes, exactly right. Yeah. Be 9 for the rest of them. Because let's say, I choose a 5 to go there, and then, I'm going to have a 2 next. I still have 9 choices for the next one. Let's say I choose a 7. I still have 9 choices for the next one. The only thing that I can't use there is the one that's right next to it. So it starts out feeling like it's going to be a factorial, but don't make assumptions. That's why I gave you that, but I want you to say, I'm not going to make assumptions. I'm going to think about what happens and what my choices are together. Does that make sense? I would actually just literally 26 times 25 times 10 times 9 times 9 times 9 times 9. I mean, when we have factorials, we've got some nice fancy buttons on the calculator that make it easier, but if we don't have that, then we just directly calculate. That's not too hard to do. If you have your own calculator, get it out. If you usually use a cell phone calculator, get that out too, but it won't do everything that I want you to do today. So if you need to borrow a calculator from me, let me know. All right, so I want you to go to the notes and let's talk a little bit more about factorials. And then while you're turning there, I'll hand you this page that is the rest of today's notes. Did I give you that already? All right, so factorials real quickly. We did this yesterday. 6 factorial means what? Oh, hold on. You can't see what I see. Let me try that again. There it goes. So 6 factorial means 6 times 5 times 4 times 3 times 2 times 1. This should be pretty obvious to recognize. 1 factorial would mean what? 1. Here's the one that's weird. Any idea what that is? You would think. If we did 1 times 0, it would still be 0. It is actually equal to 1. We have to define it that way because it makes our formulas make sense. It doesn't seem to make sense to you. And I had the same thought when I saw this for the first time. I'll show you. We're going to need it in some of the formulas that we use today. And I'll just tell you this. I know this seems like a weird topic to be doing, but the formula that we learned today is something we're going to need to use in our next unit. And we need to know where that formula came from. So I wanted to give you some introduction to it before we use it in the next unit, so you know what it is. And we're going to, in that formula, every now and then, we're going to need to see a 0 factorial. And so I want you to think of it this way. How many ways are there to arrange 6 items? 6 factorial. 6, 5, 4, 3, 2, 1. How many ways are there to arrange 1 item? 1. Put it in place. How many ways are there to arrange 0 items? 1. I don't have any items, so the only way to do that is there's nothing. Think of it as there is one way to do that. Here it is. There's nothing. It doesn't seem to make sense, but it kind of doesn't seem to make sense in the way that, what is 2 to the 0 power? 2 to the 0 power is equal to 1. It doesn't seem to make sense when we think about what an exponent means, because an exponent means like multiplying something together a bunch of times. How do we multiply something together 0 times? We kind of don't, but we define it that way because it makes the formulas that we use work, and it fits together with all of the other ideas. So sometimes we have to define a mathematical idea by what makes sense. And it doesn't seem to make sense like intuitively, but it fits the formulas that we need to fit, and I'll show you that as we move forward. And I'll show you that in particular as we use this formula in the next unit. But for now, you just need to know, what is 0 factorial? 1. Don't write 0 factorial is 0. Don't write this down. Please don't write this down. Yesterday we talked about arranging the 14 people that were in here, and we were missing a few people, and I don't remember what our numbers were, but we had something like this. How many of you, if you saw that somewhere on a test or homework assignment or whatever, might be tempted to write this? How many of you would be tempted to do that? It looks right. Happy excited 14 divided by happy excited 6 is equal to happy excited 7 divided by happy excited 3. We've divided everything by 2. If you're doing that, you're doing what feels good, what looks good. It seems to fit with math that you learned when you're in 7th grade. But does it fit with these ideas that we're talking about? You are not thinking about what that factorial means if you think you can just divide that number by 2. That first factorial means 14 times 13, 12, 11, 10, 9, 8, 7. Stop. The second one means 7, 6, 5, 4. Those two things are not even close to the same thing. So don't do that, please. Makes my heart hurt when I see that on the test. So how can we do this first example by hand? What is 6 factorial over 3 factorial? And then we see that what that does is it eliminates the last 3 numbers from the factorial, so that actually we're just calculating 6 times 5 times 4, and 6 times 5 times 4 is 30 times 4, which is 120. The next one turns out to be really easy, right? Let me show you how I like to write it as I'm thinking about it and kind of putting it in the notes. You can say this is 8 times 7 times 6 factorial. You see that? I went as far as I needed to go, and then I said I'm going to just use shorthand. The factorial symbol is just a shorthand for 6 times everything that comes below it. And on the bottom, what am I going to put? 6 times everything that goes below it. And we can cancel, and we see that the answer is now easy calculation. 8 times 7, 56. Does that make sense? Which of the next 2 is going to be the larger number?
The second one.
The first one.
Why is the first one bigger?
Because you're taking off 5.
I'm only leaving off 5 digits of that one. I'm leaving off 10 numbers of that one. So when we write this first one, it's 15 times 14 times 13 times 12, 11, 10, 9, 8, 7, 6, 5 factorial. All of that over 5 factorial. Big number. There are 2 ways to calculate that. You can type into your calculator. Please don't do it by hand in your head, because that's way too much. Type into your calculator 15 times 14 times 13 times 12 times 11 times 10 and so on. Or you can use the factorial button on your calculator. If you're using one of my calculators, you should see a button kind of upper left area that says PRB. What do you think PRB means? Probability. These types of formulas are used in probability arguments. So that probability menu, do you see the factorial key as one of those things in that menu? You can type 15 factorial divided by 5 factorial, and you get a really big number. You can do that on your cell phone. Most of your cell phone calculators will have a factorial button. What do you get?
1.09 times 10 to the 10.
So if you have E10 on your calculator, that means scientific notation multiplied by 10 to the 10th power. Does that make sense? The next answer should be a lot smaller than that, because the next answer is going to leave off a lot of that multiplication. It's just going to be 15, 14, 13, 12, 11, 10 factorial divided by 10 factorial.
I really like the answer to this question. Has anybody calculated it yet? Interesting when things turn out nice.
I think it's a surprising answer. 360, 360. Questions on that? So look at the next one. We will see problems in just a little bit where we need to be able to divide by two different factorials. Let's think about what that calculation would mean. Any ideas on how to do that? I'm not going to write down all of what it means, but it's a lot, right? On the bottom, it would be 10 factorial times 5, so that would mean 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 times 5, 4, 3, 2, 1.
But I want you to think of it this way. Pick the bigger number that's on the bottom and think about what that equals first. Look at what I circled. We've already calculated that, haven't we? That was just 15 times 14 times 13 times 12 times 11. We already canceled off the 10 factorial, but that's not everything that I need there. I haven't finished the denominator. What do I need? Does that make sense?
So you can calculate that 15, 14, 13, 12, 11 divided by 5, 4, 3, 2, 1. Make sure you use parentheses on there. Or you can calculate
Carefully using parentheses, make sure that you put 15 factorial divided by, in parentheses, 10 factorial, 5 factorial. You get a pretty nice number here as well.
what you got. Hold on.
3,030.
Hold on a second. It should be 3,003.
Okay.
I got 3,003.
Check it again. Either by doing 15, 14, 13, 12, 11 divided by parentheses 5, 4, 3, 2, 1.
Could you take the 360?
That's what I did.
Yeah, we already have the answer to that, and you can divide by 5, 4, 3, 2, 1, but make sure you're in parentheses when you do that, or divide by 5 factorial. So otherwise, it's right there. You need parentheses now. Or you can hit divided by, okay, hit, yeah, parentheses, okay, there you go. Make sense? If you were doing divided by 5 times 4 times 3 times 2 times 1 without parentheses, it stops dividing and starts multiplying. That's why you're able to say. So it was not understanding your order of operations.
So let's, now that we are a little more clear on how to deal with factorials, let's go back to some interesting problems, kind of similar to what we talked about yesterday. This is a problem we did yesterday. How many ways are there to arrange 8 students into a seating chart that has 12 chairs? So we have 8 decisions to make for 8 students. And how many ways are there to make the first choice? Remember, if I have all of you at the front of the room, and I'm going to say, I'm going to choose the first person to go sit in a chair, how many choices do I have for what chair for them to sit in? 12. And so what is our factorial answer for this going to be? So I'll tell you that the first time I did this problem this morning, because I was not thinking about it carefully, I wrote that, and that's not right. We had to go back and correct it. Why is that not right?
Because it doesn't start at 8. It goes starts from 1. Does that make sense? Like it doesn't decline, it inclines.
Sort of, but
It increases.
If we think about it this way, how many decisions do we have to make? 8. We had 12 choices for the first one, and then 11 choices for the second one. I don't want it to go all the way down to 1, but I didn't go far enough. How far do I need to go? Until everyone has a chair. How many students are there? 8. I don't care about the last 4 chairs, but I got to put 8 students in a chair. So instead of putting 8 in the denominator there, what should have been there? 4. So I want to choose 8 students. I got to organize 8 students
which means I need 8 numbers in the factorial. So how many am I leaving off of the factorial? I'm leaving off the last 4. So that 8 is not the right thing to put in the denominator. What we really want there is 4. That 4 comes from 12 minus 8. Does that make sense?
Not really.
Okay. So does it make sense that the answer would be 12 times 10 times 9 times 8 times 7 times 5?
Yes.
Yeah, okay. So does it make sense that that is equal to 12 factorial divided by 4 factorial? That's the whole of 12 factorial except for the last 4 numbers. We left off 4, 3, 2, 1 from what would have been 12 factorial.
So what would you put
Is
in
it the
12,
four?
11?
You're trying to fill out a test, you don't have enough students to fill out a test.
So, like, if you're thinking about it underneath, if I write that out in the way that we write the others, I would have 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1,
Yeah.
divided by 4, 3, 2, 1. All that cancels away, and it just leaves me with that. So, just to visualize that for a second, if I put, I'm running out of space over here, but 4, 3, 2, 1, all of that now is 12 factorial, right? I don't want that red stuff on the end. So what do I do to get rid of it? Divide by it. And when I divide by it, it cancels off and it leaves me with the answer that I want. But we're not going to divide by 8 factorial because 8 factorial would say I only want to keep the first 4 numbers of this. I want to get rid of 8 of them. So that number in the denominator is how many of them are we getting rid of? How many of them do we not really care about? Does that make more sense now? Okay. So what we're doing when we do a problem like that is we're counting what we call permutations. Permutation is the fancy mathematical word for arrangements. So I want to show you real quickly a couple of permutation questions that sound different, but they're exactly the same thing. From a stack of 8 books, how many ways are there to choose 3 of the books off the shelf? There's 3 of the books and arrange them on a shelf. How many choices do I have to make? I mean, how many books am I picking? So I got to know what comes in the first position, what goes in the second position, what goes in the third position, and I don't care about any of the rest of them. So how many choices do I have to make? How many ways are there to choose the first book? 8, 7, 6. Can we write that as factorials? 8 factorial divided by? But we'll think about it as that 5 factorial is the same thing as 8 factorial over 8 minus 3. That way we see the 3 that was in the problem. Does that make sense? That denominator number is 8 minus 3. That's where the 5 comes from. That's basically saying how many permutations, arrangements, are there of 8 items taken 3 at a time. Read the next question, and I hope you see that it's exactly the same thing. There are 8 teams in a conference, and we need to figure out who's going to be first, second, third in conference play. How many ways are there for there to be a first place winner? And then second place, and then third place. Do you see that it's exactly the same question? It's just different words, but it's exactly the same concept. Here's another problem that's exactly the same concept. There are 8 people in a club. We need to choose 3 officers, president, vice president, secretary. How many ways are there to choose the president?
8.
How many ways are there to choose the vice president? Secretary. Because no person's going to hold 2 offices. Does that make sense? So we're taking a group of things and pulling off just a couple of them and putting them in order. Does that make sense? So we call that permutations, and this is the same thing. It is 8 factorial divided by 5 factorial. Notice that the 5 factorial is coming from 8 minus 3. So in the denominator, we have to subtract off that smaller number, and that's the factorial that we divide by. There's a formula for that. It's called the permutation formula. It's written NPR. So basically what we're doing here is calculating permutations of 8 things taken 3 at a time.
And the way that we write that is 8 factorial over 8 minus 3 factorial, or 8 factorial over 5 factorial.
On the calculators you're borrowing from me, do you remember seeing NPR when you found the exclamation point? Under that probability menu, you can see the NPR. Your cell phone calculator probably has a factorial key. It may not have the probability keys, the NPR and the NCR that we'll see next. So you can type in 8P3. The way you would go to that button on your calculator, type in the 8 first, and then get the NPR thing, and then 3, and you get the same answer. What is our answer here? Anybody have it?
Same answer as we had up here. What is it? Sounds about right. Makes sense.
Is it 336? Somebody want to verify that? That actually may be a little bit. No, that's right. I'm thinking of a different problem. So 336 is correct. Does that make sense? If you read a problem and you're like, oh, this is talking about a group of this many items, and I need to pull off this many of them and arrange them, that is permutations. I want you to read the problems that are on the next page and see what's different about them. Similar to the book problem, there's a stack of 8 books, and I want to select 3 of the books. How's this different from what I did before?
If you're selecting 3 of the 8 books, you're not organizing.
We're not organizing them, exactly. We're just selecting them. I'm going to take the 3 books and put them in a bag and take them home with me. But it doesn't matter what order I put them in.
So just to give you a demonstration of how this works, let's say we've got 8 books, and I'm going to call them A, B, C, D, E, F, G, and H, because I want to be really creative right now.
Let's pick 3 books.
Simeon, which book do you want to choose out of those? Just give me a letter. F, H, and what? C. Okay. So if I choose those 3 books, if I calculated this the same way I did permutations, then it would count this differently, wouldn't it? Permutations would count those 2 outcomes differently because that's 2 different arrangements of the books. But in this situation, that's the same outcome, right? I've got the same 3 books in the middle. Are there any other ways for me to arrange those same 3 books? H, F, C. Anything else? How many total ways are there for me to arrange these books? 3 factorial. So basically, it's kind of like the Mississippi problem. I've counted too much. I need to divide by the number of ways these things could have been rearranged. So what it does is it says, I'm going to take the permutations, which was 8 factorial divided by 5 factorial, and then I'm also going to divide that by 3 factorial. It basically does this. It says, I'm putting the books into 2 groups. Here are the ones that I've chosen. Here are the ones that I've not chosen. I don't care what order any of those are arranged in. I just want to divide them into 2 groups. Does that make sense? When we divide by that factorial, it says jumble the order. We don't really care anymore. So we have 2 different groups, and we jumble the order of both of those groups, and it's just 8 factorial divided by 5 factorial, 3 factorial. The difference in the language is, does the order in which you break the books down make a difference? Look at the one below it. Similar to the other problem, right? In the last problem, we wanted first, second, third place finisher. Now what do we want? Either you go to the playoffs or you don't, right? Doesn't matter whether you finish first, second, or third. Either you go to the playoffs or you don't. Does the order in which you didn't go to the playoffs matter? No. And the order in which you did go to the playoffs doesn't really matter either. Either you go or you don't. So that's a grouping problem instead of an arrangement problem. These are called combinations, and combination is a mathematical word for grouping. And so both of these problems, the order doesn't matter. So a minute ago, I gave you a problem where I said there's a committee of, there's a club of people and they want to choose president, vice president, and treasurer, or whatever the 3 offices were.
Let's take a similar problem. I've got 8 people in a club, and I want to choose a committee of 3 people to make a decision about something. How is that problem different? Everybody on the committee is essentially equal. They don't have specific roles, they're working together. Whereas when I choose officers, it matters, you have a different responsibility to put in a different role. So the arrangement in the officers makes a difference, but the arrangement doesn't matter in the committee. Either you're on the committee or you're not. So you've got 2 groups, the ins and the outs. Does that make sense? Combinations, permutations. And so the combination formula is just exactly like the permutation formula. We would say this is combinations of 8 things taken 3 at a time. Combinations, there will be fewer answers, and look at the difference between the formulas. This was the permutation formula. What got added onto it for the combination formula? So in the combinations, we've got the bottom 2 numbers that add up to the top number. Does that make sense? The bottom 2 numbers will add up to the top number. So we're separating things into 2 groups. Is that clear? So your assignment for tomorrow in section B, let me just show you an example of one of the problems that you'll see there. This is different numbers, but same idea as one of the problems you'll see in the assignment. We have 8 points that are non-collinear is what it says in the assignment, although I think it's a different number. What does it mean for points to be non-collinear? If points are collinear, they fall on the same line. So no 3 of my 8 points fall on the same line. The problem on your homework is going to say, how many ways are there to choose 3 of those points and make a triangle out of them? In other words, my triangle could look like this. Or my triangle could look like this. How many different triangles could I draw using those 8 points? A lot. Any idea? Does it matter what order I connect the dots? So if I drew this triangle where I start with that one and go over like this, that's the same thing as drawing this triangle. But basically what I did was out of the 8 points, I picked 3 of them and I drew a triangle. When I picked those 3, how many got left out? 5. Can you see the same language here that we're doing in those other problems? Out of the 8 points, choose 3 of them. Any 3 of them will make a triangle, right? So if you want to count how many possible triangles, how many groupings of 3 points? I choose these 3 and make my triangle, and the other 5 are left out. Can you see that's exactly the same answer as the combination problems we did on that last page of the notes? It would be the 8 factorial on the top and 5 factorial, 3 factorial on the bottom. Same answer that we were doing. I don't know if we were calculating that. Did anybody get that answer?
With the last one?
Yeah.
It was 56.
56? That sounds right. Yeah. So 56 different triangles that you can make from there. There's a problem similar to that in your assignment. Questions? So when you do those combination and permutation formulas back to the 0 factorial thing, every now and then you'll end up with a 0 factorial in the denominator. And if it was 0, it wouldn't make sense. But if it's 1, it makes the formula make sense. We can't put a 0 in the denominator. We'll work on that formula some more as we move towards its usefulness in the next unit that we do. Is it interesting? A little different ways of thinking. Like I said, I'll post the extra sheet, but it won't have the mathematical work, and it'll just have the numerical answers, so you can see the way it is. Questions before you go away? You have a great break. Get some rest.
You too, Miss Arnold.
Be sure that you send me a message if you see anything about your grade that seems off. And if you want to redeem any of the zeros, be in touch with me about that. I'll talk to you about something.